the example one. An old website requires a 4-character password consisting of 3 numbers and 1 letter. Okay. A new website requires a 6-character password consisting of 3 numbers and 3 letters. How many more passwords can be made for the new website? Okay. So that's kind of the idea of where we want to get. So I'm going to go through a couple of things, and then we're going to let you guys come back to this and decide how you think that you would count this or calculate this to understand that there are a good number of options. So people that are making the decisions about what your passwords have to look like for things, they want their sites to be secure or people will stop using them, right? So they're making those decisions based on data about what are the chances someone could figure that out. Obviously, more possibilities has less chance of someone figuring it out and more unique characters. So they would look at things like this, okay? Now, we'll come back to it, and we'll decide how you guys want to calculate it. I want to address a couple notation things. Does anybody know what this is right here? Okay? Factorial. It's not like 5. Yay. Okay, that's not what it is. Okay? It means exactly what Jason was talking about. So Jason said you take a number and you multiply it by that one minus 1 times that one minus 1 times that one minus 1. And then when did you guys always stop your calculation? When you got to 1. So 5 factorial means please multiply 5 times 4 times 3 times 2 times 1. So it says start with the integer that I am giving you, or the whole number that I am giving you, and multiply it by every whole number below that until you reach 1. Okay? Which means, what would someone mean by n factorial? Can we wrap our head around what that would look like notation-wise? More? Good. It would look kind of generic, and you'd have to just kind of put a dot, dot, dot in there because you don't know how big n is. But it would still end with times 3 times 2 times 1 kind of idea. Okay? So I start with a number, the number below it, the number below that. Okay? So I'm subtracting 1 more each time to get the number below until I get to 1, and then I stop. Savannah? Yes. Okay? So you would see it written like this because n is super generic, right? We don't know what it is. But n minus 1 would be 1 below it, and n minus 2 would be the number 2 below it. And then you'll normally just see a dot, 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 because you could just keep doing that forever since you don't know how big n is. But it will end with the same pattern everything else ends with, okay? Because it's just till we get down to 1. Okay? All right, so we're going to come back to the example and talk about it after a couple of things. All right, so let's say we had 7 students waiting in line for the financial office up at the front to open. So part A says, in how many different ways could they line up at the financial office window? Okay. So this is like creating your PIN number, right? How many people are there in this problem? Read it. 7, okay? There are 7 people, okay? If they're in a new order, is that a new line to us in this problem? Yes, because how many different ways can they line up? Okay? So think about the problem you did with A, B, C. You had 3 different things, and you were trying to figure out how many ways you could order them, right? And you came up with 6 different ways, and you said the shortcut to that was 3 times 2 times 1. So I now have 7 people, and I want to see if I flip them all around in little different orders, how many different ways I can line them up. How am I going to do that calculation? Good. So she says 7 times 6 times 5 times 4, dot, 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 all the way down to 1. What would be another name for this calculation? Kenny? 7 factorial. Okay. So without a calculator, I'd write 7 factorial. On your graphing calculators, if you go to, let me just double check myself here, the math menu, and then you scroll to the right until you're on prob, which means probability, because this is used a lot in this kind of context, you will see down there a factorial thing. So you can just type in something factorial in your calculator. You don't have to type all the timesing in. Okay? All right, in part B, in how many different ways can the students be arranged in the first 3 spots of the line? Okay? Any ideas? So now we still have 7 people, but we just want to know how many different ways we can make the first 3 spots of the line. Okay? How many different ways could you choose the first person in line? 7 different ways because there are 7 people. Okay? Once you've established the first person in line, how many ways could you choose the second person in line? 6, because you don't have 7 options anymore because one has been established as the first person in line. How many different ways can you establish the third person in line? 5, right? Basically, it's this same calculation, but if somebody wants to know just how I can order the first 3, I'm not going to multiply 7 times 6 times 5 all the way down to 1. I'm only filling the first 3 spots. I have 7 options here, 6 here, and 5 here. And that's how I would calculate just the ways to arrange the first 3 spots, okay? So I would get 210, okay? And now you might be able to see why you'd want to use this counting method. If you have a problem similar to this, do I want to literally list out all the possibilities based on my 7 people, the 3 different ways I could order them? You would have 210 possibilities, okay? That would be annoying to list out, right? All right, so there is a shortcut to the calculation we were just doing, okay, that kind of, you know how part of it we calculated all 7 spots and then part we only calculated 3. If you're doing problems like that and you're talking about ordering people, we call that in math permutation, okay? So a permutation is how to arrange them in a certain order, okay? And this is the combination and the notation for it, okay? It could look like this. It could look like this, okay? N is the number of elements or the number of objects like the 7 people that are in line, okay? R is how many you are ordering, okay? So like in the first example, when we were lining up all 7 people, the calculation you were doing was 7p7, okay? Because you had 7 people and you were trying to order all 7 of them. The second calculation would have been thought of as 7p3 because you had 7 people, but you were only trying to count the ways to order 3 of them, okay? And notice what the formula does is it does the same thing we were doing before. It calculates a factorial of all the objects. But think about our 7 people. Think about our 7 people. If we wanted to order all of them, we do 7 factorial, right? If we only wanted to order those first 3 people and count those up, we didn't want to do the whole 7 factorial calculation. Instead, we only wanted this part of it, which means we were basically dividing off these factors, right? Basically, do the calculation, but cancel these ones out because I'm not counting the rest of the orders of those people. Okay, just these first 3 spots. So notice what the permutation calculation does. It calculates the factorial, and then it divides off some of the factors. So notice that if we did 7p, our last calculation, that would have been 7 factorial over 7 minus 3 factorial. Okay. 7 minus 3 is 4, so it's like 7 factorial over 4 factorial. 7 factorial means this. And 4 factorial means this. Notice it's basically taking your original idea of how to count things and crossing off the part that you're not trying to count the extra orders of. Okay? All right, so how many ways can you arrange 9 CDs one after another on a shelf? Okay? So what are the ways that we could do that calculation? Savannah? Good. So one way to do it is just to do 9 factorial because we are ordering all of the objects, right? It is a permutation because we are counting different orders, right? If I put my Madonna CD, I just said that, in front of my Red Hot Chili Pepper CD, right? That's different than if I started them the other way around. So we are counting order, okay, in the way that it goes. My husband really likes that I have that CD back in the day. All right. So you don't have to do a permutation. If you did do a permutation, what would you be doing? How many things are there? 9. How many of them are you ordering? 9. Okay, and the calculation would look like this, and this is, don't freak out. Okay, I know we can't divide by 0, but 0 factorial is not 0. Because when we do our factorials, they only multiply down to what number? 1. So we just count that as 1, and this is really the same thing as 9 factorial. And you might be like, that's not possible, Miss Dahl. Like, no, they defined it like this so they could use it to count these things. So basically, when the person came up with the permutation idea, they said, oh, you know what? Sometimes people are going to get a 0 here. There is no 0 in the way that we're calculating and counting with this multiplication. That would just be 1 in this case. So 0 factorial for us is defined as being a 1. Okay? All right, what about for part 4? In how many ways can we choose a first, second, and third baseman selected from 8 players on our team? Okay. So first of all, is there order in this problem? Okay, there is because they have different labels, right? I'm not just saying, hey, you guys are group 4. I'm saying like first baseman, second baseman, third baseman. And if I went first baseman, second baseman, third baseman, that is a different selection than the previous one, even though I used the same 3 people, right? That means order is important. This is a permutation. So how would I do the calculation here? I see Savannah and I see Kenny, Lauren. Good. There's 8 players. I'm choosing 3 of them in a distinct order. Okay? And so that would be 8 factorial over 8 minus 3 factorial, or 8 factorial over 5 factorial, which is only going to leave me with the 8 times 7 times 6 part of my calculation. Okay? Which is 336 ways. If I had no opinion on who I thought was a better first, second, or third baseman, right? This is like a random selection kind of idea. All right, so let's say that we wanted to count how many different ways we could order the letters in the word elliptical, okay? Kind of like picking a code, right? It's just like your code breaker problem, but instead of me saying your letters are A, B, C, I'm saying your letters are E, L, L, I, P, T, I, C, A, L, okay? So if this was in your code breaker problem, what's the first thing you're going to look at about the letters here? How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Is that right? Did I count right? Okay. 10 letters. If this was the code breaker problem and I gave you A, B, C, D, E, F, G, H, whatever, 10 different letters, and said arrange them, what was your shortcut? What did you guys figure out how to count them? I don't want to start writing all the possible ways to arrange the 10 letters. So what would you guys tell me to do? How would I calculate the way I could arrange 10 letters? Penny? 10 factorial. Fair enough. 10 times 9 times 8, like you guys found out, right? Here's the problem with, oh, that's interesting. Okay. Here's the problem with this. The word, or the letters in the word elliptical are different than me saying A, B, C, D, E, F, G, H, whatever, 10 letters. Okay. What's the problem with the letters here? Samantha. There's a lot of L's going on. So if I said, hey guys, here's one version of this, E-L-L. Here's another version. They're different. I switched the L's. Right? So does it appear to be different when there's repeated letters? No, right? It technically is a different, I did switch the L's, okay? But is it really a different order? No. Okay, so that's this idea of distinguishable permutations. I cannot distinguish this one from this one. They are the same to me unless your L's had little subscripts that made them different. So basically, it was 10 factorial, but when you counted 10 factorial, you counted all of these that looked like this with the shuffling of the L's. And let me just give you an idea. How many looked exactly like this? There's an L here, an L here, and an L here. How many different ways are there that I could switch up those L's that you would never be able to tell them apart? 6. 3 times 2 times 1, right? This kind of idea. So what I need to do to my 10 factorial is something that should have been counted once was counted 6 times. And it wasn't just counted 6 times, it was counted 6 times and then all the different arrangements of the letters around them, right? Like everything that would branch off of it was counted 6 times. So I basically need to divide out all of those things that I extra counted, okay? So I divide by 3 factorial, and again, I'm choosing the 3 because there were 3 L's, okay? What else is going to be a problem here? Andrew? The I's, right? The same thing's going to occur, but less times, right? Because there's only 2 I's. So how am I going to take care of all the places where the I's repeated? Okay? I also need to divide by 2 factorial because of those. So I was counting the same thing so many different times because the other things were being arranged around it. Technically, the L's were switched, but you couldn't tell.
Wouldn't a code like that just make it easier for us to do that?
Yes. Okay. So that's why we want to count the number of distinguishable permutations. So sometimes that's important to be able to count those or to acknowledge that those aren't distinguishable. Okay. So we wouldn't have more options in that case. All right. So that's what we're doing. And then we would finish that calculation to count how many possibilities that there are. Okay? All right. What if I want to arrange 3 letters or pick a group of 3 letters? So first, to arrange 3, let's say I gave you A, B, C, D. If you wanted to arrange them, that's what we've been doing, right? You guys already told me. Okay, I would do 4 times 3 times 2, right? That's how I would pick it, or I would do the permutation calculation. But what if I didn't care about the order, okay? So if I pick A, and then I pick B, and then I pick C, those are not different. They are now the same. Because I'm just saying, oh, I need 3 people to walk up to the office. Does it matter who I pick first, second, or third? No. You're not ranked first baseman, second baseman, and third baseman. There's no ranking. You guys get nothing different. You are a group going together. That means that this is no longer a new option. ABC covers ABC, ACB, BAC, CAB. Do you get what I'm saying? So will there be more options this way or less options if I don't care about the order? Michelle? Less. Okay? So we call this a combination, or the number of ways to choose something. And you'll often hear people say, like, 4 choose 3. Okay? It basically is the permutation calculation, but then it has to do what we did for the word elliptical. It has to basically divide all the things out that you used to think were different, because A, B, C was different from A, C, B was different from B, A, C. Those are now all the same. Okay? So in this case, because you were choosing 3 letters, you used to have 3 times 2 times 1, and that would be 6 ways that you could make that. Those are now all just one group. Okay? So that's why that's getting divided by the 3 factorial or the 6. So you'll see that the combination formula is basically the same as the permutation formula, but divided by that extra piece because now you don't get to arrange them and count them as different options. Those are all the same option. Okay? Like the word elliptical and arranging the L's. So part of the hard part is going to be choosing the right thing. Okay, that's the hardest part in counting them. We can multiply, we can use permutations, we can use combinations. So let's say I have 20 songs on my MP3 player. Yeah, I know, kind of old. Okay. So you have time to listen to 4 of them, and how many different ways can you select the 4 songs if order doesn't matter? So you just want to select the 4 songs you're going to listen to. You're not selecting, I'm listening to this first, this second, this third, and this fourth. Just what 4 songs will I listen to? So what type of calculation would I be doing here? Lauren? Good. Okay, a combination because, song 1, 2, 3, 4 is the same as song 4, 3, 2, 1. It's the same 4 songs. I don't care about the order. So in the first problem, I would do a combination. There are 20 songs, and I'm picking 4. Okay, and this would be divided by 20 minus 4 factorial and also 4 factorial. In that same menu where I showed you factorial, there's an NPR and an NCR button, so in your math probability menu. And so you can literally type into your calculator 20. Then you can go pick the NCR button, and then you can type 4 and press enter, and it will do this calculation. Okay? So it will count it up for you if you know what you're doing. Okay, for part B, it says a raffle at a school carnival awards prizes of $100, $50, $25, and $10. 25 raffle tickets are sold. How many different ways can the prizes be distributed? So I have 25 people, and I'm picking out 4 of them as winners, right? That part is fine. The question is, do I need to count this in a way where order matters or not? In other words, am I using a permutation or am I using a combination? What do you guys think? Does it matter the order in which I select the people? Am I selecting a group of people who all have the same outcome, or within that group, are they being assigned an order or a role that would be different depending on their position? Savannah. Good. Since there are 4 different prize amounts, the order does matter, right? It's different for you if you're the person that gets the $100 than if you're the person that gets the $25. So everyone selected is not ranked equally. The order would matter, which means we want to calculate it with a permutation. So 25 raffle tickets, and we're picking 4. So this would be 25 factorial divided by 25 minus 4 factorial. And again, the calculator can do a bunch of that for you. All right, so last question, okay. How many diagonals does a regular octagon have? Okay, so one way you could do this is you could draw it. Okay, what is the definition of a diagonal from geometry? What do you do to draw a diagonal in a figure? Michelle? Okay, you go from one corner to another corner, okay? They also call them vertices. All right. How many vertices does an octagon have? 8. So in order to draw a diagonal out of the 8 vertices, I have to choose 2 to connect together. Does that make sense? And that would choose a diagonal. Do I want to count point A to point B as a separate option from point B to point A? Is that a different diagonal? No. So do I care about order? Do I want to count AB different from BA? No. So I don't want permutation. I want combination. So I have 8 options. I need to choose 2 to make my diagonal. Now there's one little thing to this that makes that not the entire answer. If I take any of my vertices in an octagon and choose 2 of them, what could happen? Jason? Good. So to be a diagonal, it cannot be the vertex that's right next to it one way or the other, or instead of drawing a diagonal, I just traced over one of the sides of the octagon, right? How many times would that happen? 8, because the octagon has 8 sides. So I would do this calculation, but then I would have to subtract 8. So I can't let go of some of the common sense part. Combinations and permutations aren't going to count and do everything for you, but when you want to count groups of things, you can see it could get very tedious to count up all the options by trying to arrange the groups by hand. So this will help us do some of that. Okay? All right. So when you guys come in tomorrow, we'll talk a little bit more about that example 1. Okay? How many passwords were there in the old website? How many passwords are there on the new website? Your homework